In this question part A, they ask us to prove two triangles are congruent, which is this triangle and also this triangle. But they overlap, so it may be more difficult to read. And based on the given information, they tell us that BD is equal to EC. At the same time, they also tell you that DM is equal to ME. So one thing very important is coming out is this section BE is equal to DC. Both of them is just the whole line minus 1 unit. So for two triangles, we already proved that one pair of sides are the same. It seems that given BD equal to EC, given. Therefore, BE is equal to the whole line minus EC. We can change EC in terms of BD, which is equal to DC. So we proved that one pair of lines to conclude BE equal to DC. We have one pair of lines already. After that, they also tell us that this angle are the same. So angle ADC is equal to angle AEB. This is given. Finally, the last thing is because these two angles are the same, so this is isosceles triangle. We can say that these two lines are also the same length, which give the final pair of lines which are the same. Since angle ADC is equal to angle AEB, therefore we know that AD is equal to AE. The reason is very specific. It's called side opposites equal angle. I just draw one of the triangle ACD. We have one pair of side, two pair of side, one angle between them. So we have enough evidence to make the conclusion triangle ACD congruent to triangle ABE. The reason is SAS, side angle side. And then proceed to part B. They say that AD is 15. So this line is 15 cm. And then BD is 7. DE is 18. And because this is the midpoint, so which means that FE section is 9. We know pretty well about this triangle, and then we have to find AM. That means it seems like vertical, but you're not sure whether it is right angle at this moment. So you may make your own decision whether this is right angle. If you look at triangle ADM, triangle AEM, they are congruent because of one pair of sides, one pair of angles, and also one pair of sides here. So they are congruent, which means that this angle bisect by AM. This is 90 degrees. So part B1, since angle AMD is equal to 90 degrees. Therefore, we can use Pythagoras theorem. AM squared plus 9 squared is equal to the longest side squared. Again, 3 to 4 to 5, so this is 12. AM is 12 cm. After that, they ask you is triangle ABE a right angle triangle. We are talking about triangle ABE, so you better draw an isolated diagram. And then you will try to write down as much as you can about this triangle. AE, which is equal to AD here, so it's also 15. BE, we just add these three sections together. 18 plus 7, we get 25. That means our question is, if we can find out this one, then we can use converse of Pythagoras theorem to see whether this is right angle triangle. So now our mission is find out AB. And don't forget that B1 and 2 are connected. We have 12. We also have BM this section. And we already showed this one is 90 degree. So AB consider triangle AMB. We know that 12 square plus 7 plus 9 bracket square is equal to AB square. So our common ratio again, 3 to 4 to 5, so this is 20. Just times 4 times. We find out that our target is 20. Now is to compare these three sides to see whether it's fulfilled the Pythagoras theorem condition. Very important is you have to imagine that you don't know that. You are going to find out whether they are the same. So don't write that. Don't write 20 square plus 15 square equal to 25 square directly. Don't write that. We are just considering AE square plus AB square is equal to 15 square plus 20 square, which equal to 625. And at the same time, we consider BE square is equal to 25 square equal to 625. Since AE square plus AB square equal to BE square, it's because we discovered that by calculation. That's why triangle ABE is a right angle triangle.